So this is the 20th lecture of this course, and today we'll discuss topic that is K-map. A very important topic called K-map. Now, what do you mean by this K-map first of all, and what is it used for? When I say K-map is abbreviated for Carnot's map. K-A-R-N-A-U-G-H-S, Carnot's map. This stands for Carnot's map, and the purpose of this K-map is simply to simplify. It is a, you can say it is a graphical method to simplify a Boolean function. A Boolean function, especially when the Boolean function is in canonical SOAP and POS form. SOAP and canonical POS form, if the expression is in this form. Although it can be done for non-canonical also, but normally we solve it for a canonical SOAP form or a sum of minterms or product of maxterms forms. Now, just look at this, why we are going for this. Suppose I have a function, Boolean expression, which is a function of a, b, c, d, and suppose I say that it is equal to a, b, c, d plus 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 a, b, c, d, and I put a bar here, I put a bar here, I put a bar on this, I put a bar here. This is what it is, for example. And suppose I say that minimizes, or I take any other term here also. So it is a, b, c, d, again you have a bar here and a bar here, whatever. I say minimize this. You need a lot of Boolean manipulations here. You have to use various Boolean rules and laws in order to minimize it, so that it can be realized with minimum hardware. So to avoid this difficulty, there is a method that is called K-map method to solve this Boolean expression without involving these Boolean identities in between. So this is the main purpose of this K-map, to simplify the Boolean function, which should be in canonical SOAP or in canonical POS form. That generally you have this expression, these are canonical. I say that this is f is equal to, it is summation of some minterms, or I say that f is product of certain maxterms that I have already discussed within the previous lectures. Now this K-map can be for n number of variables, but at this point for your syllabus you have the solution of Boolean functions by K-map for 2 variables, for 3 variables, and for 4 variables. Beyond this, although it can be done for 5 and 6 variables also, although it's a limitation of it, but we'll go for 2, 3 and 4 variables K-map, or the solution of Boolean functions if it is of 2 variables, 3 variables or 4 variable Boolean function. Now first of all, how to frame this K-map, that is very important. K-map for 2 variables or n number of variables, what K-map is nothing, it is simply a square or rectangle which is divided into certain blocks. A block is divided into certain blocks, and this block is called a cell. And the number of cells in a K-map, is equal to 2 to the power n. N is the number of variables of the Boolean function. For example, I say that f is a function of a, b and c. This implies that the value of n is equal to 3, so it will have 2 to the power 3, that is equal to 8 cells. Similarly, if n is equal to 2, it will be for 4 cells. If n is equal to 4, it will have 16 cells. So first of all, this complete block is divided into 2 to the power n number of cells. So now I'll start with 2 variable K-map. So the function of this, it is a graphical method to simplify Boolean functions. This is the main purpose of this, to simplify Boolean function. So first of all, I'll tell you how to frame the K-map, very first thing. So I'll start with 2 variable K-map. 2 variable K-map. Now this K-map can be for a SOAP form, canonical SOAP form, or it can be for canonical POS form also. I'll discuss one by one. So first of all, I'll go for two variable K-map. Two variable K-map means if there are two variables A and B. If there are two variables A and B. So only four possibilities are there, that is either both are 0, 0, 1, 1, 0 and 1, 1. These are the four possibilities. That is, if I say in terms of min terms, it can be A bar, B bar, A bar, B, A, B, A, B bar, and it is A, B here. So A can have two values 0 and 1, B can have values either 0 or 1, and in combination it can have four possibilities. Decimal 0 to 3. If I say the decimal equivalent of this is 0, this is 1, this is 2 and this is 3. These are the decimal equivalent of 0, 0, 0, 1 is 1, 1, 0 is 2 and 1, 1 is 3 in decimal. So first of all, what I do, I simply make a square here. I simply draw a square. I simply draw a square, and on one side, suppose I say it is A and on the other side it is B. This side it is A, and I divide this into 4 cells. 2 to the power 2, that is 4 cells. I divide this into 4 equal cells. Now A can have a value either 0 or A can have a value 1. Similarly, B can have a value 0 or B can have a value 1. I hope this is clear to you. Now if this is for min term, I am drawing this initially for a min term or for a SOAP form. Min term, sum of min terms, summation of min terms I can say, or for a SOAP form. Now every cell will represent a min term. Now 0 means, when I say min term, 0 represents A bar. Just see, this 0, it represents A bar and 1 represents A. Similarly, 0 represents B bar, and this 1 corresponding to B, it represents B. Now look at the value of this cell. It is the intersection of A bar, B bar. If you see, it is A bar dot B bar. On the other hand, it is A, B bar. I hope this is clear. This is A from this side and B bar from this side. Similarly, on this side, it is A bar, B. This is A bar, B. And if you see this intersection of A and B from here, it is AB. Now look at the decimal equivalent of this. The decimal equivalent of this number, you can say, I am writing on the right hand bottom of this. This is 0, 0. I can say it is 0, 0. So 0, 0 decimal equivalent is 0. This decimal equivalent is 0 here. This is 0, A and 1. First I am writing A, then then value of B. First value of A, then value of B. Value of A is 0 and B is 1. So it is 0, 1. I can say that this is 0, 1. 0, 1 decimal equivalent is 1. This decimal equivalent is 2. And this decimal equivalent is 3. So for a min term, I represent this equivalently. How do we draw this? We don't draw all these things while solving the problem. We simply frame a K-map. We frame a K-map here, divide it into number of 2 to the power n number of cells. On one side, I write this A. On this side, I am writing B. Means this is representing B, this is representing A. Then this is A bar. Just see, and this is A bar and A, and here I write B bar and this is B. I hope this is clear to you, and I simply write the decimal equivalent of this. What I have written here, I skip all these things while solving the problem. It is 0, 1, 2 and 3. This is the K-map for a canonical SOAP form where every cell is representing a min term. Only 4 min terms are possible for 2 inputs. Similarly, I can make for max terms also. If I have to draw a K-map, 2 variable K-map for max terms, how will I make 2 variable for K-map for max terms? Just see, for max terms, again I draw a rectangle or a square, I can say. Divide into 4 parts. On one side I say it is A, and on the other side it is B. On horizontal side this is A, and on vertical side it is B here. Now A can have value 0, 1. Similarly B can have value 0 or 1. Now when I say that this is for max term, This is for a maxterm where every cell corresponds to a maxterm. Now 0 corresponds to A bar. This 0, this corresponds to A, not A bar. 0 corresponds to A and the variable corresponds to A bar. This variable, it corresponds to A bar. On the other hand, this is B and this is B bar. Now look at this. Look at this. This value, if you see, it is A plus B here. This value is nothing. It is combination of this and this. So maxterm, of course, it is a product of sum. So you will find a sum here. It is A plus B. This is from here. It is A and this is B. This is A bar from this side and B from this side. It is A bar plus B. This, if you see, it is A plus B bar. A plus B bar. This cell, A bar plus B bar. A bar plus B bar. Now look at the decimal equivalent. For a maxterm, variable corresponds to 0. This variable, it corresponds to 0. This is 0, 0. This is 1, 0. This is 0, 1. And this is 1, 1. If I write the decimal equivalent of this, it is same. If you find the decimal equivalent of this particular number here, see the decimal 0, 0 is 0, then 0, 1 is 1, this is 2 and this is 3. Of course decimal equivalent will be same. So the equivalently I can write this. I skip rest all other things. I simply draw a square and divide this into 2 to the power n number of cells, that is 4 cells. On one side I say that this is on horizontal side, this is representing A, and on vertical side this is representing B, and I write this as A means 0, 1. 1 is A bar for a maxterm. For a maxterm, variable represented by complement, 0 represented by the variable. Say this is B and this is B bar, and I simply write down the decimal equivalent of this, which will be same as 0, 1, 2, 3 from here. This is C. 0, 1, 2 and 3. That's all I have to draw finally while solving the problem. I need either this one or this one while solving the problem. So I hope that how to frame a two variable K-map, either for canonical SOAP form where every cell will represent a minterm, or for a canonical POS form where every cell will represent a maxterm. I hope that this is clear to you. Next, let's take the 3 variable K-map. Second heading I'll take 3 variable K-map. 3 variable K-map. How to frame a 3 variable K-map? 3 variable K-map means there are 8 possibilities, that is 2 to the power 3. So it will be divided into 8 cells. So suppose you have 3 variables A, B and C. The total possibilities are 8. Input possibilities are 8. That is, A can have value 0 or 1, B can have only values 0 and 1, C can have only values 0 and 1, and the combination can have values 0, 0, 0, 0, 0, 1, 0, 1, 0, 3, decimal equivalent 4, decimal equivalent 5, decimal equivalent 6 and decimal equivalent 7. This the decimal equivalent of the 0, 0, 0 is 0. This is 1, 2, 3, 4, 5, 6 and 7. These are the decimal equivalents of these numbers. 0, 0, 1 is 1, 0, 1, 0 is 2, 0, 1, 1 is 3, 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 0 is 6 and 1, 1, 1 is 7. So what I simply do, if I see in minterm, suppose I say what is the corresponding minterm of this. The corresponding minterm of this will be A bar, B bar, C bar. On the other hand, the corresponding maxterm of this, if I have to find the maxterm of this, I am not writing all, the maxterm of this will be A plus B plus C. 0 represents the variable. So it is A plus B plus C. So finally what I do, I simply draw a rectangle here. How to frame this K-map? I draw a rectangle here. Just see. I draw this rectangle. I am drawing a rectangle here. And on one side, So I divide this rectangle into 8 cells because 3 variables, so 2 to the power 3 is 8. So I divide this into 8 cells first of all. And on one side I say it is AB, combination of A and B, and on the other side I am showing that this is C here. Now AB can have values 0, 0, 0, 1, 1, 0 and 1, 1. So the discipline that will follow here, that is very important. It is 0, 0, 0, 1, 1, 0 and 1, 1. Why I have taken this fashion? Why not 1, 0 here and 1, 1 here? I'll just tell you in a moment. But the point is that it is like this. C can have only 2 values, either 0 or 1. Now I am drawing it for min terms first of all. I am drawing it that every cell is representing a min term or it is in canonical SOAP form. For SOAP form, how I frame this K-map first of all. Now, when I say 0, 0, 0 means first element is representing the value of A and second is representing the value of B. So it is A bar, B bar, I can say that this is nothing. It is representing A bar, B bar. This is representing A bar, B. This represents AB and this represents AB bar. Similarly, this represents C bar and this represents C. Now look at this. This cell corresponds to A bar, B bar, C bar. A bar, B bar, C bar. Just see. It is intersection of this and this. Then this is A bar, BC, A bar, B from here and C bar from here. Then this is AB, C bar. Then this is AB bar, C bar. This one if you see, A bar, B bar, C from this side. So it is A bar, B bar, C. This represents A bar, B, C. This represents ABC and this represents AB bar, C. Now this is a min term, so I am representing every variable complement by a 0 and this function variable itself by 1. So this will be 0, 0, 0 if you see. This is 0, 0, 1. This is 0, 1, 0. This is 0, 1, 1. This is 1, 1, 0. This is 1, 1, 1. This is 1, 0, 0. This is 0, 1, 0. Now if I write the decimal equivalent of this, look at the decimal equivalent of this will be, if I write down the decimal equivalent of this, let me use this blue color. It will be 0. This is 1. This is 2. 0, 1, 0 is 2. This is 3. Then this is 4. Then it should be 1, 0, 1. I'm sorry. 1, 0, 1. 1, 0, 1. This is 5. This is 6. And this is 7. I hope that this is clear to you. And now when I solve the problem, I don't write all these things. This is just to give you the idea how to get it. So what I do, I simply make a rectangle and divide this rectangle into 16 cells. I divide this rectangle into, not 16 cells, I'm sorry, 8 cells. Since it is 3 variable, I divide this into 8 cells. These are the 8 cells. And on one side I say it is AB on this side and C on this side. I don't write all these things. Either I write in this binary bits form or I can write in the variables form. I find it comfortable to write in the variables form. So I write this as A bar, B bar, A bar, B bar, A bar, B, AB and AB bar. I hope this is clear to you. And this is C bar and this is C. The decimal equivalent of this is 0, 1, 2, 3. I have told you how. 0, 1, 2, 3, 4, 5,